Are you ready? Everybody hear me? Now you hear me? Okay. I will review the last quiz. Okay, last time to review the concept why I quiz for you. Are you ready now? Okay. Last time this is the quiz that you do last time. Okay. Everybody must find total sum of this mass retaining on each if. Okay. What you get? What you get? For total. 1, 2, 3. Okay. After that, to compute the percentage retaining on each SIP, clear? For this SIP, you get 0. That's right. For this SIP, what you get? 100. And after this, what you get? 0. The total sum should be what? 100. And after you get the percentage retaining, okay? We compute the cumulative retaining on each SIP. For this SIP, 0. That's right. Yes or not? This is what you get for this SIP. Cumulative 100. Next, 100. And next. No, okay, no compute. Clear? And then find the total sum for this. What you get? 400. And after that, you get the finite modular for this example equal to what? 400 divided by 100 is look like normalize this number, okay? Normalize percentage with percentage. You get 4.000. I told you to compute at least what significant number. I told you last time, 4 number. If you write 100, what is significant number you use? 0, 0, okay? Clear? Don't forget. This course, I would like to check that your significant figure is good or not when you compute. Clear? For this number, it should be what? Only 0, okay? Only 4 is significant. Okay, everybody? So, what does this mean when you get finite product of this aggregate equal to 4? It means that when your aggregate is written on this sheet, number 16, you get the finite product of this line at the top. You get equal to 4. For another example, if your aggregate is written on sheet number 30 equal to 100, so the finite product it should be what? should be what? If your aggregate only retain on SIP number 30, not retain on SIP number 16, what you get? Finite morat of this. What you get? Can you tell me? Not retain on number 16, only retain on number 30. What you get for finite morat? 3. Yes. Then when you compute for every SIP, you get the finite morat look like this. Is written on the pen, you get 0. On this SIP, you get number 5, number 6, 7, 8, and 9. Due to your last SIP is SIP 1 inch and a half. Okay, 1 inch and a half is a lot for concrete. But for another, what to say? Because almost the concrete is used for concrete structure such as building. But for them, maybe you use the lot again more than this size. Maybe 2 inch, 3 inch, something like this. Okay? So your finite morat may be more than this. Up to the practical work you use. Clear? But almost for this class, almost your concrete familiar to building structure. So the last number is near, not more than number 9. Hear what I'm saying now? Come back. You know that when your aggregate retain on each SIP only, you get finite morat look like that. Then, what does it mean? Because I told you finite morat look like the what I last say, index number. That's right. Yes. Okay. Then today I would like you to convert the index number to be the average size number. Okay, in millimeter. Are you ready now? I will show you the table of American Standard SIP. You see this table? You see?
Yes, Ajahn.
Okay, the American Standard SIP almost used for this class, not use Taylor Standard SIP. Use American Standard. Follow ASTM, American Standard Stating Material code. Okay? That code told you that the size of the whole of each SIP look like the whole of the SIP is look like not rectangular, it look like what to say, square. Clear? The whole of the SIP is look like square. Not so the SIP size is told you look like only one dimension, something like this. Yeah. For SIP number 1.5, this side near the number 37.5. For another, you can see. Yeah. And then the last quiz is show you the example that the aggregate is written on only SIP number 16. That's right. Yes or not? When the aggregate is can pass from the last side to this side, what does it mean? It's written on this SIP. It means the aggregate size is more than 1.18 millimeter. That's right or not? Because it can retain on this SIP, not plus this SIP. But your aggregate is past digits, that right? Yes. What does it mean? So your aggregates have the size less than 2.36. Then I would like everybody to compute what? To compute the average aggregates size retained on each SIP in millimeter. How to find the average for aggregate size in this SIP by the whole of the each SIP? How to find this average? It can pass this number and retain on this number. What does it mean? So your aggregate size is between these two numbers. Okay? Yes. Then how to compute average? Can you tell me? Almost average is a linear interpolation technique because you have only two samples. So the average should be what? 1.18 plus what number? Divide by what?
2.
Yes, what you get now? Can you tell me? What you get?
1.77.
1.77. Don't forget that in this class, okay, I told you to use significant formula for calculation. How many? How many we use for this class? How many significant number?
4 cup. 4.
Yes.
4 sir.
Then we should write what?
0.
0. But this number is begin with number 1 or number 2 or number 9.
Number 1.
So
Okay.
it should be used significant more than the other number. That's why I told you last time. Clear? So for this SIP, you know already how to compute the average aggregate size that retained on this SIP. How about the other? For number 30, can you tell me? For number 30, average aggregate size, what it should be? Try by yourself. Point 890. Okay. And next, number 50.
It's 0.4500. 4500.
4500. Okay. Next. Yes. Next.
0.225.
Point what?
225.
Yes.
2250.
0. Yes. How about the last Joseph, such as number 8? What do you get? $3.555. Yes. How about number 4? $7.125. CP per 8 inch. Point 25. Okay, it's between it number 1. Don't forget to put 0. Clear? How about the paper 4?
It's 28.25.
28.25 should have 0 or not?
No ครับ
No, because it's cover 4 significant figure already. Yes. How about this? How about this number? Because you don't know the upper side. That's right or not?
Remain the same.
No, not remain the same. You should know this concept. What concept that American Standard Sheet is used to calculate? You must compare the sheet size between each sheet first. How different? Tell me. This and this. How different?
Half of it.
This compared to this, half or 2 times? Compare this to upper. Half. That's right. But compare upper to small is 2 times by approximate. Yes or not?
Yes.
This side near 2 times, okay? This side 2 times. Yeah? This side near 2 times. Okay? This side 2 times. This side 2 times. This side near 2 times. So the concept of American sheep is use the sheep only the size different 2 times, okay? Then the bigger sheep, if you use for this calculation, the size should be what? 2 times. What is a bigger size?
56.
The sheep size first. Sheep size first. Before.
25.
Yes, 25. Then you use this and this to calculate. You get 55 point what?
25.
Yes, 25.
25.
Okay. Due to the concrete is not used aggregates that look like dust. Okay, or mass. Why? Because it's weird the cement to use in the mix design too much. Why the small sheet that used to retain the aggregate why it should be number 100? Because if it's less than number 200, it's called dust. Okay, or mass. Clear? Then almost engineer not use that aggregate in the mix design because it will make your concrete or mortar mix design to use cement too much. Clear this point or not? So When you would like to compute the aggregates that retain on the pan, not retain on the sieve, by the same concept. So the smaller size than sieve number 100, it should be what? A half. Yes. What it should be? 0. What?
0.075.
Yes, 0.75. 0. Then the aggregate that written on this pen, it should be average aggregate size should be what?
It is 0.1125.
Okay, 1125, because it's begin with number 1. Clear? So significant figure should be used more than the other number. Okay? In the final examination, I give you only the first and the second column of the table. But the third column you must compute by yourself. Okay? Because the first and the second is come from American Standard size. Okay? But the third column is, I would like you to compute what? Average aggregate size. Why we compute this? Because we will use this number in the mixed design later. Clear? We use in the mixed design. Why we use in the mixed design? To compare the page or the multi-page that used in the mixed design, how much it is from this number. It can guide you how to approximate or calculate by approximate the page that enough to cover the aggregate in mixed design, something like this. Clear? Any question?
No.
Okay. Then, after you know how to what? To find the average aggregate size that depend on each sieve. The next example. So, I would like to show you the general example of your aggregate when you do on the lab. Clear? For this example, you get that your aggregate list only on sieve number 8, number 16 until pan. And you find the total number equal to 11, something like this. Then, on the first lab, the first step is talk about sieve analysis. Sieve analysis means what? The objective is to find finite modulus of your aggregate. Is the first objective. Okay? But the second objective that you must know is to find average aggregate size. When you do this, you have two objectives. One, to find finite modulus. The second, to find average aggregate size of your sample. Okay? For this example, last time you know how to compute the percentage retained on each sieve. For this sieve, what it should be? What it should be? 0, 0, 0. And how about this? Four, four, five.
It is 9.09 cup.
9
Point
zero
0
9.
90 cup.
After zero,
Zero.
What the fuck, yeah?
after zero, what is this?
0 cup.
Zero. After zero, it should be 1. You must round up, round down, but the concept round up, round down too. After zero, the number is more than 5 or less than 5 from your compute in your calculator.
Oh, wow.
It's 0 actually. It's 9 cup.
9. Okay, you
Yes.
must say the fifth significant is more than 5 or less than 5. Clear? Is more than 5, you should round up. If it's less than 5, you can round down. Clear or not? So what it should be for this number?
1 thousand, 1, 1.
1.
1 cup.
Okay, don't forget to check round up, round down too. Okay. How about next?
18.18.
18.18.
Yes, Azam.
Yes. Correct? Correct concept or not? I mean not. Because it begin with number what? The first significant, it begin with number what? The first significant, it begin with number 1. Don't forget carefully, because if it begin with number 1, this significant number will cause the error in computation too much. So I would like you to what? Give your error, okay, in your compute. So I would like everybody to use significant number more than 4 than other number in computation. Clear? Then what it should be? 2. How about next?
It is 27.273 cup.
27.
273. 27.
27 have 3 or not? No, because it's begin with number what? Number 2. Okay, larger than number 1. Clear? What is number no need? So this number you compute already. 9 point what? 091.
091.
27.27. 9.091. Then you find the total, what you get. It's round up already, that's right. Yes or not yes. Because the number is not 100. That's why or not? When you sum up this together, it gets exactly 100 or not? What is what that number?
It is 99.995.
Yes, it's a 99.995. Okay. The fifth significant is number 5. Okay. Due to the concept of round up, if the significant is number 5, it have two way to round. If the fourth significant is even number, is round down. But if the fourth significant number is odd, it should round up. Clear this point? in my concept. Clear or not? So the fifth significance is number 5. It have two way to round. It can round up, it can round down. Okay? Then if the fourth significance is odd number, it should round up. And if the fourth significance is even number, it should round down. Get this point? So you can round to 100.00. Get what I'm saying? Clear?
Clear ครับ
So after you compute the percentage retained on each SIP already, next to compute the cumulative percentage retaining. Okay? For this SIP, 0. For this SIP, 0. That's right. You should do like this. Yes or not? Sum from top until your SIP number. This should be what? 9.091. How about this? 27.27. Yes or not?
Yes.
Next. 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 What you get?
It is 63.63.
Next.
It is 90.90.
In pen compute or not? This
It
one?
is 99.99.
No. Okay. Because it's a pen. Okay. No compute. And after that, find sum of this number. What you get?
99.99.
No? What? The pen not compute. That's right. Yes or not? When you find the cumulative percentage retaining, I told you this concept not compute on the pen. Yes or not? And after that, find sum of this number together from SIP number 1.5 until SIP number 100. What you get? The total what you get?
245.43.
Keep your significant number to correct.
Or
To,
44.
okay. 45.4. That's right. Yes or not? Now you can find your what? Your finite product of this aggregate equal to what? When you compare the total sum of cumulative retaining normalized percentage again, what you get is get the index. It should be what?
2.454.
Yes, 454. This number is have in the table or not? You know already? What you know already? You know that when you are get finite product, okay, that written on each SIP, what is the average aggregate size? It should be, that's right, from the last skin. Yes or not? Wait for a moment. I will show. From the last skin, you compute the average aggregate size. That's right. Yes or not? And you will know what is the finite product number that written on each SIP. That's right. Yes or not? From the quiz, okay? But your number is between what number? Yeah, between 2 and 3, okay? From this concept, almost engineering or almost engineer will use the concept of linear interpolation almost, okay? Because engineer look like the simple technique to find what you get, clear or not? So in this course, I will also use linear interpolation technique too, clear? Clear or not? How to do linear interpolation techniques? You know that it's between 2 and 3. And you know already if it's finite product is equal to 2, your average aggregate size should be 0.450 millimeter. Yes or not? Yes or not? Last skin, we compute like this? Yes or not?
Yes.
Okay, you must maintain your 4 significant figure too. Clear? Then I will use this technique of linear interpolation. Will show you. I think you familiar with linear interpolation technique before or not? Everybody almost familiar or not? Linear interpolation techniques. No, not no.
Not sure ครับ
Not sure. Okay. Come back. Because you get 2.454. Yes. Wait for a moment. You remember the number already of you have the number of your average aggregate size already. That's right. The technique how to do, draw the graph. Okay. Horizontal is a finite modulus. Vertical axis is a average aggregate size. You know that it's between SIP number what? Number what? Finite is number 2 and 3. Yes. SIP number 30 and 50. Yes or not? 2 is what? Number 50. Yes. 3 is number 30. Yes or not? And what is average aggregate size that retain on for finite equal to 2? What is average aggregate size? 0. What? Yes, 450. For number 3, yes, 0.8. 8900. Okay. Linear is a linear line. Okay. Draw the line between your two coordinate point. Draw the line. You get that? Linear operation thing is mean draw. Draw what is your behavior. It should be you use linear. It mean behavior is linear. Draw linear line. Clear? Your finite product is here. That's right. 2.454. Yes or not? When you project to this point, projection to the graph and project to vertical axis, what you get? You get the average aggregate size of your aggregates. I will use D as the size. A is aggregate, okay? Average aggregate size, it should be 1. This you must find. My name is DA. Clear? Look like diameter of your aggregate, something like this. Clear or not? How to find this? By linear interpolation techniques. From the first to the second point that you know, you can draw the line like this. What you get? You get triangular shape. Yes or not? Yes or not? Yes. Yes or not?
Yes.
Yes, Ajahn. Yes, yes.
And not only that, for the point that you would like to find, excuse me, oh. Reduce. This look like what? It's a small triangle. Yes or not? Yes. You know the concept of similar triangle already. Yes or not? Everybody? Yes? Yes or not? Yes. Yes. Okay. I assign this side length equal to what I say A. Okay. This side B. For this side, the length I define as E. And this side should be F. Clear? Is the length of each side integral triangle shape. Then, what is your similar triangle rule? Tell me. Can you tell me? A by D equal or A by B? Oh, excuse me. So, A by B equal
E by F.
yes? Yes or not? Okay, wait a minute. I would like everybody to raise your hand in Google Meet to show you who is agree. is your friend? Raise your hand. In Google Meet. How many? 12? 12 person? How about the other? Oh, 14. Oh, 14 person. Raise your hand. How about the other man? How about the other guy? Bantri? Ventura? 14 people, person in this class. Is your similar triangle, triangular blue. 14% told me like this. How about Bantri? Bantri? Bantri 3? Ventura? I call your name correctly or not? Ventura. Okay. How about the other? 16 now, 16 person. Not 14, 16 person now. This ratio is not similar kangaroo. This concept is a slope concept. But this slope concept is equal to tan theta. Tan theta is a trigonometry. Trigonometry is not similar triangle. It's a slope concept or tan theta of trigonometry concept. Okay. Everybody know that how to find slope. Vertical divided by horizontal is means slope. Clear? Tan theta. If this triangle or what to say?
Hello, Arjan. We can't see your screen.
What?
Cannot see screen.
Excuse me?
We can see your screen. You didn't share your screen.
Sorry. You see now? %16 told me that this your similar kangaroo, but it's not similar kangaroo, it's a slope technique or trigonometry technique because slope and tan theta is equal the same meaning. You get what I'm saying now? But it's not similar triangle rule. What is similar triangle rule? Everybody can tell me? Can you tell me? It's not similar triangle rule. It's a trigonometry or trigonometry technique or slope technique. Can use, but it's not similar triangle rule. Okay. You don't know this concept? Or it's not on the skin? Or it's no, sorry. Wait a minute. Oh, it's not on the skin. Why it's be like that? Why it's be like that? Oh, Sorry. Now you see the screen? Correct screen or not?
Yes, Ajahn. Now we can see the screen in triangle.
Okay. Every to be last time 16% to me like your friend to me first. A divided by B equal to E by F. Yes? It's a slope of trigonometry techniques because slope and tan theta is equal. Okay? These two concepts is equal. Clear not? Slope is equal vertical length divided by horizontal length. It's the same of tan theta concept of trigonometry. It's the same meaning, but it's not similar triangle technique. Okay? The similar triangle rule is told you what? Can you tell me? A by E. Not A by B, A by E equal to B by what?
F, Ajahn.
Yes, F. If this side I call C and this side I call G, what you get? Is equal C by G. Okay? This what? This the similar triangle rule. What does it call for this? It's called expansion scale. Okay? Similar triangle rule is told you two things. One is expansion scale. For similar side, it have the ratio equal together. For A and E is a similar side, yes or not? B and F is similar side, yes or not? G and C is similar side. This concept, you use the last number A by E, B by F, C by G, so the number you get is more than 1. Clear or not? More than 1 is mean what? It's called expansion scale. But in similar triangle, it told you two things. You can find another. Another is E by A equal to what? Equal to what? F by B equal to G by C. Okay? This number less than 1. Clear or not? This concept is mean reduction scale. Okay, similar triangle rule told you expansion scale and what? Reduction scale. Clear or not? It's the same for three side ratio. Okay? In this concept, what is the good concept for similar triangle rule we use everybody can use slope concept, okay, can use trigonometry concept, but I not prefer to use it because it's not correct similar triangle rule concept. I would like you to use similar triangle rule concept, but similar triangle rule concept has two concepts: expansion scale and reduction scale. For the proper to this problem, the good ratio it should be reduction scale. Why it should be reduction scale? Because the size or the number you would like to find or to determine is the fraction. of this ratio. It look like you would like to find E something like this. Yes or not? Everybody? Why to find this? Because this side A you will know from this number and this number. Yes or not? You can calculate A, yes, from this graph. Yes or not? B you can find. And also F you can find. Yeah, except E. So, because if you use the correct concept, you get the idea too quickly, to let you know very quickly. Clear? So, we will use this concept, reduction scale technique. E by A equal to F by B. Why to find this? Because you will know the reduction scale from F by B. Clear? What is the number F? F will come from this number and this number. Yes or not? Yes or not? Yes. Okay, 2.454 minus 2 for F. Divide by B. What is B? 3 minus 2. Yes or not? Yes? Yes or not? Yes. This is a B. B come from here and here. Yes or not?
Yes.
So now you know the reduction scale from this ratio and from this side. Clear? Yes? You don't know E. Yes or not? Yes, but E is come from what? Come from the average aggregate size you would like to know compared to the beginning number 0.45. So E is come from your average aggregate size value minus by 0.45. You get that? This is a number E. Divided by A is come from what? The last and the okay, from the margin 0. The last number 890 minus 0.4500. Yes or not? This is A. Clear? For this E. Yes or not? Everybody can see? Everybody can see that? You get that, everybody?
Yes, Ajahn.
This is F. This is B. That's right. Yes. From the
Yes, Ajahn.
reduction scale concept, what you can do? Because on the right hand is a ratio of reduction scale equal to the ratio you would like to find, and you can move this number to the opposite side. What you get? Yes or not? When you like to determine A, you must move this number to the other side because it's the divide. Move to opposite side is multiply. Yes or not? On the left side is a dA minus by 0.45 and then move 0.45. After that, what you get? You get
So 0.18. Oh wait.
yes. You get like this. 0. What? What you get? Everybody, what you get?
0.6632.
6632. In millimeter. About the other, get the same. The same or not? Yes or not?
Yeah.
Yeah. Wait for a moment. Other get the same. 66. Yes or not? Yes.
0.649.
6498.
No, Ajahn, wrong.
0.6498.
Yeah.
Yeah.
649.
98.
Round up. That's right. Okay. It's a correct answer. Clear? You must find this ratio first. After that, multiply this ratio to this side. When you know the ratio is mean what? The ratio is told you that the small triangle is have the ratio less than the bigger triangle. How many? When you know this number, you can what? To use it as the scale to multiply to the size of the bigger triangle, and you will get the small triangle. Something like this is the meaning of similar triangle technique. Everybody must to practice too much because this number is a reduction scale. Okay, when you know the reduction scale, you can use the reduction scale to multiply to the side of the larger triangle. What you get will multiply the larger side of the triangle. You get the side of what? The side of this, the smaller triangle. Clear? Clear or not? When you get this side, you put this height. Yes or not? This height is a what? Is a 0.45. What you get from here to here is mean what? It mean the average aggregate side. Clear? Clear or not, everybody?
Clear, Ajahn.
Okay. Today, I will check your concept. How to find the average aggregate side. So, any question before I let you have quit? Second quit. Two minutes.
Yes.
Okay, 2 minutes. I would like everybody prepare what? Prepare the table look like last time. Okay, one. And the second to prepare the graph before compute. Clear or not? Okay, everybody prepare your paper first. You have 5 minutes to do, okay? For the second quiz. When you do your quiz more than 5 minutes, every 1 minute your score will reduce 20%, okay? Don't forget this minute. Try to prepare your paper first. Everybody, are you ready?
No, no, Ajahn.
Don't write down your ID and your name in the preparing pictures, okay? Prepare your table, prepare the graph, okay, and your equation, how to find your average aggregate size too, clear? Maybe someone write down something like this.
I don't
A equal something like this. The number plus minus. Yes. Something like this. Okay. and your FM. Equal to what? Something like this. Clear? Prepare carefully.
Average for
Where?
for move your mic. You can use any calculation you can do, okay? But you have only 5 minutes. Send your kit via individual line. Clear? Clear now, everybody? I already sent an example, Ajahn.
Send your preparing.
Yeah, I already sent you preparing.
Do we need to send it to you first, Sam?
Okay. Don't forget to write your name and ID too, R3, in the sheet. R3. Okay. You can prepare, write down the equation, okay? Yang Chi, you cannot write the graph in the same sheet. You must send to photo. Sarah look like the same.
Do I have to write graph in the same sheet, Arjan?
Yeah, if you the same sheet, you will take the photo only one time, okay, not 2 times. That's right. It's very quick when you
Okay.
send the quick. Yeah. Sarah itu
Okay.
Giraffe. Giraffe Gola. Giraffe Gorala.
Yes, Ajahn.
If you prepare in one sheet, it's good for you.
I will send in single photos, Ajahn, the answer.
Because when you send two photo, it take time, okay? Yeah. Sunny is good. Sunny mean. Reverse. Okay.
I'm ready ครับ
Oh, so now everybody ready? When you're ready, raise your hand in Google Meet, Tommy. Okay. When you're ready, raise your hand in Google Meet. I will send the quiz to the group line. Yeah. Prepare your. How many person now? 11. Only 11. Now 12. After quit, after you send quit, take a bed. No, not take a bed. Take a break. Okay. Until the class start again on 2 o'clock. Yeah. Everybody.
เคลียร์ครับ
Now 13%. Ready. Only 13%. How about the other 5? Ring rim. Ventura. Methodine. How about you? Are you ready? I wait until before 30, okay? It take time. Are you ready now, everybody?
yes อาจารย์
Raise your hand. Okay, go. See on right. Go. You get the quiz already, everybody?
no ครับ
Not yet.
No, Ajahn, no.
Everybody get or not?
Yes. No problem. Oh, here. Yeah. Right. Yes, bro.
Excuse me. Are you ready?
Yes, Ajahn.
Excuse me. Are you ready now?
Yes, Ajahn.
Hello. Are you ready? The internet of university is have some error. That's right. Um, Wait him first or something. Excuse me. Excuse me. Can you hear me? Can you hear me? Hello. 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 Oh, error. Internet error.
Hello, Ajahn. Hello, Ajahn. Are you still alive? Sadiq.
Only one man. Can you hear me?
Yes, Ajahn. Yes.
Internet error.
Yes, Ajahn.
Wait.
I
Only
can
one?
hear you. I'm ready.
Only one. Only one man.
Varajan. Hello.
Hello. How
Hello.
many can join? Wait, about how many now? About 10 minutes first, no? Wait for 10 minutes.
We can start, Ajahn. We'll study together, Ajahn. We'll study
Oh,
together.
you're in the same class, same room.
Yeah, Ajahn. We are
How many in your
together.
room, son? 4. Now your group have 4. How about another? Lima? Lima in the same room.
Yes, Ajahn. Yes, sir.
How about the other?
Namka.
Pema. Mm-hmm.
No, Jen, I can hear you.
Now you can join. Yes. I see also like you.
And Roshni, Ajahn. Roshni Kurum is Roshni Rai.
Roshni also the same. How about user? User stay with San or not? Mm-hmm. Now your group 4, Pema 5. How about Patrick? Sợi, Giraffe, Coralla?
Yes, Ajahn.
Yes. Okay, raise your hand that you when you're ready now. Raise your hand to show me who can hear me. Okay. Except Yang Chen, Rajni. How to find Yang Chen? Who near Yang Chen? Oh, Yang Chen, now you can join.
Ajahn, they disconnected again.
Patrick?
Ajahn, I think they're having some problem with the
Rosni?
Wi-Fi.
How about Yang Chen?
Ajahn, her Wi-Fi is not working.
Yes, Ajahn. Sorry, Ajahn,
Yes.
my internet was not working well. Kap. Sorry, Kap.
Okay. So now Yang Chen can join. Yang Chen.
Yes, Arjan.
Okay, now you can join. Yes.
Yes, Arjan.
Okay. I'm not sure. Last time I talked about homework assignment, that's right. Yes, yes. So I told everybody because last week is the first week. Yes. I also told you that everybody must send your homework. Homework 1, 2, until 10. Something like this. The first homework not sent more than week 2 on Wednesday 12 p.m. Yes or not?
Yes.
And do in A4 paper, okay? You can send me as MS document or PDF document file to sirinaranan@yahoo.com. Last time I told you like this? Yes or not?
Yes, Ajahn.
Okay. So be careful, okay, to do your homework. Not more than the deadline that I give you, okay? The first homework not more than this week of Wednesday, okay? The second homework not more than the third week on Wednesday, 12 p.m. Clear? The third homework not more than week 4, okay? Then you can count what is the deadline for each homework assignment. Yes or not?
Yes.
Okay. Don't forget to do that. And not only that, I think I'm not sure what you and me talk together. I talk about the report or not?
Yes, you did, Ajahn.
Okay, you must find the paper I told you like that. Yes or not? Yes, yes. You know the topic of your paper is about mixture additive porcelain, something like this, performance high concrete. Yes. Yes, of the concrete, something like that. Yes. Not more than the topic, not more than when. The first paper, the first paper. You must send me the first paper to let me prove not more than when. Yes.
September 5.
Okay. And the last report of your all 5 paper, not more than
October 13.
Okay. Everybody know that's clear. So today we just finished the concept and the detail to use in lab 1 already about the finite boron and the average aggregate size. Okay, everybody get this point already, yes or not? Okay, next concept we will talk about what? I think everybody know this word or know the concept and not. I'm not sure the concept, but I think everybody familiar with this word. Wait for a moment. Everybody know this word?
Yes, Ajahn.
Specific gravity. What does it mean of specific gravity? Or the equation you will know. Okay, the density of material compared to density of water. Okay. The density is look like normalized unit. Okay, look like normalized unit, but it's not normalized until you normalize by density of water. So specific gravity is look like normalized number. Okay, that compared to the water. So to do this, the density is referred to the weight per volume. Yes or not? Yes. So it means that what this normalized is mean? It means that when you compare in the same volume, it look like to compare the weight of material to the weight of water too. Clear? Why? Because you normalize the density in the same volume. Clear or not? Then when you divide this together, it look like the weight of material compared to the weight of water in the same volume. Clear or not? When you can compare the weight, when you use the material and the water the same volume. Clear? So this specific gravity is been how heavy of your material compared to water. Something like this. In this subject, the material you will use for basics is have what? You know C? C is what? I told last time. Cement, water, sand, and crushed stone. Okay? So the specific gravity of material you will find on this class for cement is in lab number 4. Sand and crushed stone in lab number 2. Clear or not? So today the concept I will talk about is about the specific gravity of crushed stone and sand, how you can do in the lab. So from this meaning, how to practice on the lab. The concept that is used to let you to can compare the weight of the material, how it is. by the concept weight the material in water. How to weight the material or measure the material? I assume that what? Excuse me. Assume this is a material. This is water. And your material is in the water, but it have the cable. Cable connect to the measuring device. Okay, clear or not? And measuring device is report the weight of your material in water. This is the weight of material in water. The concept to use is from this basic. I will ask everybody know how to draw the free body diagram of material in water or not? One, write your body of material. Okay. Next, write down the reaction. What is the reaction to this material? Yes, from a buoyancy force 1. Okay, this in buoyancy force. Next, the free body of this material. 1, you draw buoyancy force. Next, weight of material. Okay, I write down the weight. Oh, excuse me. Weight of material. Okay. Weight of material is mean W is look like weight of material in air. Nobody know that the weight of material almost measure in air, not measure in water. Okay. And next, from this figure, yes, the tension from the cable. Yes or not? And the tension of cable is acting to the what? Measuring device. Yes or not? And measuring device, it report you what? It report to you that it is the weight of material in water. Clear? And what happened? Due to this and this is the same what? The same cable. We neglect the weight of the cable. So the tension, from here and here is look like what? If this is action, this is a reaction. Is this the reaction? This is the action. Okay? The same. Due to the third law of Newton is told you like that. Clear or not? So now from this device and tension. So tension, now you know the tension of the cable is the same like the weight of material in water. You get that? You get what I'm saying or not? From this figure, you know that this device is only the force that act on this device, only the tension from the cable. Clear? So the measuring device is report only the weight or the force of this tension force only. So due to you measure what? You measure the weight of material in water. So the tension of the cable, it is the same meaning of weight of material in water too. Clear this point? Everybody clear this point or not? Come back to the free body of material in the water. From this, because this is stable in static mode, what you get if this is a free body diagram, what you get next? Everybody takes static course before. You get static course already. From free body diagram, what you get next? T equal W minus F. This comes from the summation of force in vertical direction equal to 0 from Newton's rule. Clear or not? From this equilibrium equation, okay, in vertical direction, what you get? The tension force in cable equal to the weight of material minus the what? The buoyancy force. Okay? You get this? Okay. This is the first meaning. The second meaning that you get is buoyancy force equal to what? Equal to what? Weight of material minus tension force. But tension force is equal to what? Is equal to the weight of material in water. W is the weight of material in air by normal. By normal practice, the weight of material is not in air, it's not in water. If you can measure the weight of material in water, what happens? You can find the buoyancy force. After you know the buoyancy force, what you get? From this meaning, what meaning? Specific gravity of material. It comes from this definition: density of material by density of water. Yes? Yes or not? Yes. You know or not? Is from here. You can measure weight of material divided by buoyancy force. You know or not? How you can find this? How you can find this? You know or not? This meaning is equal to the weight of material divided by buoyancy force. This meaning is mean specific gravity of material. You know or not? Can you tell me? No or not? No. No before. Okay. So next, I will show you something to let you get this point. Okay. Wait for a minute. You must imagine. Normally, is you not see, but you must imagine. What you imagine? This is the level of water. Under this is the water, okay? No material in this, but assume what? Assume it look like you have some shape. Look like rectangular shape or cylindrical shape, something like this. look like the box. Can you imagine? Assume in the water you look like some block. You know or not? Assume. Normally you don't. This box is filled with what now? This box is in the water. So this box, what is in this box? You know? What is in this box? What? Excuse me? Excuse me? What? What do you think? No. No, not air.
Atom.
It's because I told you this now, this is the water, okay? This line. This line is mean the top, the surface of water, surface. Imagine this is the surface of water. And from here, from this surface, imagine it look like the block inside this. Normally it's not half, but imagine it look like some block in this. What is in this? Yes, it's a water. Okay, so this water is have the weight. That's right or not? Yes. And under this box, when you use the concept of your free body for this material, what act to this in Fibonacci diagram? What is this? Yes. So this box of water under that is have buoyancy force. That's right. Yes or not? So this buoyancy force and this water is different or not? Yes, it's the same. Know you now that this buoyancy force is equal to the weight of water. What is this meaning? The weight of water. Before you take the water out, it's a water. That's right. Yes or not? Imagine that if you can take the water out, if you take the water out, the water come up to this space. No space inside this. Clear? But imagine, take it out and take the material into this, such as your aggregate or something, have the same size. Clear or not? Clear or not clear? Now the weight of this water, what happened to it? It appear or disappear? When you take it out, what happened to this water? No. Because you know that the buoyancy force equal to the weight of water before it disappeared. That's right. Yes, but now you take this water out. Before you take water out, you know that this buoyancy force is equal to the weight of water first. But now this water, when you take it out, it disappears. Yes or not? So I will give you the definition of buoyancy force. You must know that buoyancy force is equal to the weight of water that disappears too. So now you get what I'm saying? Yes. So when you imagine what? This is your material block. Now it's a block of material now. This block of material is have its weight. That's right. It have the volume. Yes or not? Yes. And the volume of this pure water and this volume of material is the same. Yes, it's the same. Okay. So your material density equal to what? The weight of material divided by its volume. Yes or not? So for water density equal to what? Equal to the weight of water that is disappear divided by the volume of water that is disappear. You get what I'm saying? You get what I'm saying or not? Because before you take the water out, this water is have its weight. Okay? So this water is have its weight. This weight we call weight of what? Weight of water that is disappear or is a disappear water weight. Clear or not? Divided by the volume of water that is disappear. But this volume of water that is disappear is the same the volume of material. So this can cancel together. What you get? You get the weight of material divided by the weight of water that is disappear or the disappear water weight. But you know that this weight of water is disappear. It mean what? It mean your buoyancy force. Clear? Then the technique almost engineer use to find what? To find specific gravity of material. He used the method of what? Method of weight. By measuring weight of material in the air and measuring weight of material in water. Why? Because the difference between the weight of material in air compared with the weight of material in water, what you get? You get what? You get the buoyancy force. Okay? And now you can find the ratio between the weight of material in air by buoyancy force. What you get? You get specific gravity of material. Clear at this point? So almost engineer almost use this concept. How to find specific gravity of material. One, measure the weight of material in the air. Second, measure the weight of material in the water. From this equation, you will get specific gravity of material. Hear what I'm saying now? Everybody get what I'm saying now? So you must know the not only from definition, density of material compared to density of water, but in practice, you can find specific gravity of material by the weight of material in air divided by buoyancy force. How to find buoyancy force? You will know that buoyancy force from this diagram. It shows you that it is the difference between the weight of material in the air with the weight of material in water. Clear? So now you must know these two formula. These are another meaning of specific gravity of material. But in practical, you must do like this. Clear? Measure two things. And we will use this concept for what material? For sand material and cruststone material in lab number 2. Okay? How to do in the lab? I will talk to you later. But from this concept, due to how to measure the weight of material in water, how to do in practice? Because your cruststone have many particles, your sand also have many particles. Okay? So how to what? Now to measure the weight of material in water, like practical work, the engineer will have another concept. What concept? Assume you have some container. Two container, the same container. The first one, I assume some line from here. Wait for a moment. Assume this. Excuse me. It's the same level. This container have the weight of container. Clear not? Before it's filled with something. These two container is the same container. So these two container have the same weight. Clear not? The first container, it contain what? One, your material. Second, water. Most material is sink in the water on the bottom. But assume that in this material, no water inside. We are not, no water inside. Only material only. No space, no anything. Imagine something like this. So, this material have its weight. Clear? Clear not? So the first container have the weight of material inside. The second container, imagine that this space, before you fill with material, it should be what? Last concept is the water. Before you fill with material, you remember? Is this the space is filled with water with the same volume of material. This weight, it should be what? Remember last time? You remember last time? What is this weight? It is the weight of disappear water. Okay? It is the weight of disappear water. So this beaker also have the weight of disappear water. You fill two container with full water at the level you know, okay? So this beaker also have water. It also have water. But this water and this water is the same volume, so it means the same weight. Okay? This I will become the remain water, something like this. The same. Remain water. The same. if you can fill your material into the some container and you fill the water or pour the water into this container until the level you know the volume it is, and measuring this weight, you get what? You get that this container will have the weight of container plus the weight of material plus the weight of remaining water. This is weight number 1 from bigger one or from container 1. From container 2, this have what? This have the weight of container. Not only that, also have the weight of disappear water inside, and the weight of remaining water is number 2. This beaker and this beaker or this container have the same volume at the same level that you will know. If you measure the weight of beaker 1 or the container 1 compared to the weight of container 2 or the weight of beaker 2 and find the difference between container 1 and container 2, what you get from this meaning? This and this cancel. This and this cancel. What you get? You get the difference between the weight of material and the weight of disappear water. Okay? And you know that the weight of disappear water, what it mean? The weight of disappear water, what it mean? It mean buoyancy force. Yes? And this, and from last slide, the difference between the weight of material and buoyancy force, what it mean? The tension force. But this tension force is mean what? It mean the weight of material in water. So I would like to conclude that in practical work, you cannot measure the weight of material directly to the device, but you can measure the weight of the container. It look like what? Indirect method. How to find the weight of material in water by measuring the weight of the container that contain the water and contain the material inside it. This look like famous technique that is used how to find the weight of material in water. Why is used this technique? Because what? Because your material is have many particles such as sand. It's a small particle. You cannot directly measure the weight of each sand or the bundle of your sand or the batch of your sand together. So engineer almost use the beaker or some container that you know the level of water to do this. So this technique almost used for sand. Okay? But not for sand. You can use for crushed stone too. They are not clear. Everybody? Okay. So when you do on the lab, you have two methods. One is direct method. The direct method is what? You have the device. You can measure what? You can measure some basket. This basket is not normal basket. You know baskets have the hole, something like this. Yes or not? Yes or not? Yes. The basket. So if it in the water, this basket can let the water go inside easily. Yes or not? Yes or not? Yes. So then some engineer use the basket to measure what? To measure the weight of material in the water. You do like that. But when you do, you must keep this hole of the basket small as it is, smaller than the size of your class stone. But you can use for sand because sand very very small. The size of sand is very small. Okay. Sometimes the hole of the basket is not small enough. Clear or not? So almost in the lab, the basket almost used for class stone and use the bigger for sand. Then ASTM use bigger to measure the specificity of sand and use the measuring device with the basket to find the specificity of stone in water. But in lab number 3, it has some container, look like cylindrical container. In this lab, I would like you to use this container to find specificity of material by this technique. Okay or not? Normally, specificity is in lab number 2. Okay? In lab number 2 is you have two equipment. One is a bigger. The second bigger more used for sand. Okay? And you have the basket. The basket is used for cut stone because you can put the cut stone inside here. They are not. Then in lab number 2, we will talk this concept again when you do this lab. I will talk the concept how to find it first. Clear or not? So, are you get this point what I'm saying? Get or not get? Get or not this concept? This concept I call indirect method. Okay? Because you cannot measure the weight of material directly. But this look like measure directly. You have the wire, you have basket, you have the cable. So I call this direct method. Clear? Everybody? Clear or not? So for the next example, wait for a moment. Wait for a moment. You see this? You see this? Okay. Status 1. Status 1 is only the weight of container only. Okay? Because you not feel anything inside this. And measure the weight of this container. You get only the weight of container only. Clear? The weight of container equal to the weight of status 1. This is status 2. This container filled with full water. Okay, full water. Because you know the level. Yeah, not? This concept is in lab number 3. This weight of status 2 equal to what? Equal to weight of container plus weight of full water. Okay. Yeah. Yeah. This status 3, the third state. This state have only the weight of container. Not only container inside, also have a half of water too. Okay? Something like this. Excuse me. Half of water inside. Okay. You fill a half of water inside this container. And from this status 3, you pour your material to this container. What you get? You will have the material and the weight of a half water inside. Not only that, you also have the weight of material too. Yeah. So then state 4 is have what? 1, the same container. 2, the weight of a half of water. 3, the weight of material. Okay. On the lab 1 and 2 you do, but state 3 is the first state for state 4. After state 4, you pour the water again into this, pour water until you get full water at the same level with step 2. Clear not? Fill water into this until you get full water. It means step 5. From the last concept of indirect method, I would like you to tell me that in the direct method is compared between which state in this figure. Can you tell me? Can you tell me? What is the state in this figure from number 1 to number 5 is familiar to the indirect method technique? Which figure? Everybody. 5 and what? Yes, 5 and 2. Because it's the same level of water. Clear? It's the same level. I told you in the concept, it's much the same level of water. Then, the different weight between state 5 and state 2, what you get from that concept? It means what? Can you tell me? It means what? What I told you last? Weight of material, what? What alphabet we use? Tension. It means the weight of material in water. Okay? Clear this point? Clear not? Not only that, you also can find the weight of material that you put into the container. Yes or not? Yes or not? Yes. Which state that refer to the weight of material in this figure? Which state? Refer to the weight of material in air. Yes, it's a difference between number 4 and compared to number what? Number 3. Why? Because step 3, you fill the water first and measure the weight of this state. Okay? You have the weight of container plus the weight of a half of water. After that, you fill the material into this state 3. You get state 4. Okay? You fill the material into this, and the water is come up. But you have the material inside. In this container, you have what? You have the weight of material inside this. Yes or not? So when you find the difference between state 4 and state 3, what you get? You get the weight of material. Clear this point? Yes or not? Everybody get that? Yes. When you know the weight of material in air and the weight of material in water, then you can find specific gravity of material or not? Yes. Your equation should be what? Yes. So are you ready now? Prepare your A4 paper or something. Yes. Oh my God. I would like you to concentrate because we just
Hello. At least give us more minutes.
how many minutes you would like? I give you 5 minutes.
No, 10 minutes.
Or last time it should be 10 minutes, but I give you 5 first.
No,
But
we sometimes don't know whether answer is correct or wrong. Please give us 10 minutes.
no, 10 minutes. Last time should be 10 minutes. It's a good. Okay. I will consider the next. Last week I will consider later. But this is only 5 state. Okay, only 5 state. Do we know this concept already? Yes or not? How to find weight of material? How to find weight material in water? When you know the weight of material in air and weight of material in water, you can find what? Specific gravity of material. This is the objective that I would like to test you. Last skin. You want to say the last skin first? Okay, wait a minute. You mean this? Yes or not? Okay. Okay, excuse me. See that? Let's big something like this. Okay. When you're ready, you can tell me. I will stop the skin for a little bit first. Okay. When you're ready, raise your hand. When you prepare your A4 paper already. Okay. When you prepare your name, your status, when you're ready, raise your hand. 1, 2, 3, 4, 5, 6. Now only 6%. After this quiz, I will see you again next Wednesday, okay?
Okay.
Almost everybody stay at Rangsit dormitory or not?
No, Ajahn.
No, except
Yes,
practice
Arjan.
Yang Chen.
Yes, Arjan.
No.
No one.
No ครับ
Oh, outside country.
Yes.
Oh, who outside the country? Oh, they outside.
Ajahn, I'm gonna go back home in like 2 weeks. Kap.
Oh, 2 weeks.
Kap, Ajahn.
Because Rangsit University told everybody that everybody can go to the university around October. I'm not sure. Okay.
Okay, Kap, Ajahn. Thank
But
you.
if Rangsit University change the time, okay, change the time to entry, maybe a half of, maybe this month, because this month is September already. Okay. Until the half of this month, if it's changed, okay, you can come to prepare the material sand and your class stone on the lab. Because I would like everybody to keep sand and class stone for your own. Okay. How many? 60 kilogram sand and 60 kilogram class stone in the bucket. Okay, you must have the bag, not the bucket, the bag. You must prepare the bag to fill sand and fill class stone to the bag before you do the lab. Okay, how many for sand? 60 kilogram. How many for class stone? 60 kilogram. Clear?
อาจารย์ครับ when can we do lab
Maybe the mid of, not the mid, around October. Maybe term break. The term break of this term is around 11 of October. Okay.
and will we do it like every day lab or we do once a week ครับ
It look like you must use the free time that you have. Okay. The free time
โอเคครับ
on that week. Maybe on Wednesday, if you have the free time, not on Wednesday another day, you must do by yourself. Okay, because lab number 1 until lab number 3 is an individual lab. I told you before. Yes, so everybody must do by yourself for first until the third lab. And after that, you can do together as a group. It's called group lab. Okay. ครับ what to say? Not space, file container. Yes, you must get file container status 1 until status 5. Because the last figure I show you is a quit. Okay. Yeah. You prepare that first. I would like you to prepare the figure. I will give you what? The weight of container for file status. Yeah.
Ajahn, can you check your line? I sent the preparation one.
You send your paper. Okay, your file status must have status 1, 2, 3, 4, 5. Write down. W1, W2, W3, W4, W5, 2. Okay. How about the other? Would like me to check your preparation test or not? I give you 5 minutes to do, okay? Too long. Somebody maybe take 1 minute.
ready ครับ
Everybody ready? Wait a little bit. Are you ready now?
Yes, Ajahn.
Okay. 5 minutes to do. Yeah? You see on the screen?
Yes, Ajahn.
Clearly or not? Clearly?
Yes, Ajahn can see clearly now.
Okay, let's do it. Yes, to find the weight of material in air, the weight of material in water, and also specific gravity of material. Three answer. Weight of material in air, weight of material in water, and specific gravity of material. 5 minutes.
Arjun, can we leave if we submit our answer?
Excuse me.
Ajan, after we submit our quiz, we can leave, right?
Oh, you would like to continue or not? P3?
No, no, Ajan. I thought I finished the quiz, so like we can leave the class or not. I just want to ask.
Okay, you can leave. See you again on next week.
No, no, Ajan. If class is longer, then I can stay, Ajan. I was just asking.
I think today is nap already.
Okay.
Okay.
Kapun kap, Ajan.
Okay.
Thank you, Ajan.
See you, John. Thank you.
See you. See you. See you.
Thank you, Jan. Goodbye, Jan.
Yes, thank you. You're welcome.
Thank you, Ajahn.
You're
Thank you,
welcome.
Ajahn.